If you've been following along, you know that I've been trying to build a robot that's capable of finding pennies to add to my own coin collection. Over the last couple of weeks, I figured out how to design this coin stacking mechanism so that it's easily 3D printable, and I also figured out a lot of the electronics that are going to go into this. The other thing that I figured out this week was the form factor of the coin stacking wheel. You may recognize the size of this wheel as it matches not only the coin grabber but the coin sorter. But if you look inside, it's just a little bit different. And this was a real challenge to figure out how to model in CAD because it contains lots of little parts that all have different tapers on them, and I had to replicate those shapes around the center point. But I think I'm really happy with the way it turned out. The challenge for this was that it required a third stepper motor to actually turn the stacking mechanism, but the motor hat that I was using previously only allowed for two stepper motors. And as you saw in those previous videos, I needed those for the other two functions of the CoinBot, mainly coin sorting and coin handling. It took a long time to actually get all the soldering worked out and figure out which pins are going to control this breakout board, but I actually got that working, so I'm pretty excited about that. Now, I thought I could get away with just using a 5-volt motor, and that would have made it a lot easier because I don't really need that stepper function for the coin stacking mechanism. It just needs to run until there's a full stack, and then we can turn that off with a limit switch. But it turns out that the 5-volt DC motors just weren't powerful enough to turn that stacking mechanism when it's loaded up with coins. So I had to go back to using a stepper motor. I want to be able to stop it though with a limit switch, and I haven't quite got the electronics figured out. I did a little bit of troubleshooting, and that limit switch is only producing about 1.3 volts when it should be up to 3 volts, which is the control voltage of the Raspberry Pi. And as you can see here, it works really well. It actually pulls a coin from the bottom, rotates it up to the top, and throws a coin on top of the stack. And it keeps doing that until either the hopper is empty or until the stack is full. At least that's what I wanted to do in theory. That will all be controlled by the limit switch, and I'll get that working in a later video. And if everything works out, when this stops spinning, it will leave a nice stack of pennies on the desk when I pull the coin stacker up. And there it is. I'm pretty happy with this result. And we're going to use this stack to pull a coin off the bottom using the coin grabber, rotate it between the two cameras, take pictures of both sides of the coin, and then identify it with a machine learning algorithm that will develop over the next couple of months. But I think that's enough for this video. And as always, if you have feedback for me about how to build a better coin stacker or how to make better YouTube videos, please leave a comment down below. For now, that's my 2 cents. Thanks for watching, everyone, and stay awesome.